Yeah, so this following section, section 4, we'll be exploring other satellite products. So we've seen mainly imagery, we've seen a burned area collection as well, but we can also, satellites can also collect information about climate, weather, and various compounds present in the atmosphere. These satellites leverage portions of the electromagnetic spectrum and how different objects and compounds reflect when hit with sunlight in various wavelengths. And for this particular section, we'll work with methane data and climate and weather data. For this, we'll work with this checkpoint F1.2E. So we can go back here to our code. I'm gonna open F1.2E checkpoint, and I'll clear here my working script. And I will copy here the code from line 1 until 33 and paste here in this clean script. So we'll check some weather and climate data. We'll start with this methane data, which is from the European Space Agency. We can check here the details of this data set. So the first line here of code I have is defining my methane data set. I have this variable called methane, and I am defining to this collection. And if I copy and paste the asset ID here, I can see that it's data from the Sentinel-5B sensor, and it's methane data. These are methane estimates. We'll be working specifically, if I go here to the bands tab, we'll be working specifically with this first band, which is the column average dry air mixing ratio of methane as parts per billion. So we'll be looking into methane data. This is a ratio as parts per billion, sorry. So we'll be working with this band, so levels of methane in the atmosphere. And I am going to filter this methane data set. First here, I'm using the select function. This is also in the previous chapter, F1.1. Here I'm selecting that specific band that I just showed you with, will give us information, the ratio of methane. And I'm filtering by date. So I have a specific date here, November 28th of 2018. So I'm filtering by this specific date. And I'm grabbing the first image of that collection, which is the image from exactly November 28th, 2018. And as we've seen, we can define some visualization parameters by defining a new variable. And that's what I'm doing here. I'm defining this variable where I'm defining some visualization parameters. Here within the visualization parameters, we'll be working with a palette of colors. So we're looking, pixels will be classified into a different color depending on the methane level, the methane pixel value they have. So here we define this palette where we have colors, from black, blue, purple, cyan, green, yellow, and red. So values, here we're defining minimum value of 1770, and here 1920. So values close to this minimum value will be black, and values close to this maximum value will be red. And then all values in between will have these colors in between this list here of this palette list. And then I'm centering my map to this image here, to this filtered collection that I returned this first image, and I'm adding that to the map. So if I click run, it took a while, but you can see the idea here is to see the levels of methane here in the African continent. Again, because we defined this palette of colors, minimum values will be close to the black color and maximum values close to the red color, and all the values in between will have blue, purple, cyan, green, or yellow colors. So we can see, for example, here, in this northwestern part of the African continent, we have higher values of methane compared here to the southwestern African continent, where we have these colors which are close to the purple and black, which represents lower values of methane. So we have here higher concentrations of methane, and down here lower concentrations of methane. So just another example of a data set that is available in Earth Engine. And we'll go back to the checkpoint and check another example again of weather and climate data. So I'll copy from line 35 to the end of this checkpoint, and I'll paste here. So we've seen methane. Now we work with this other data set. This one is also European. This one's from the European Center for Medium Range Weather Forecast Reanalysis, so it's the Euro 5 data set. And this data set gives average air temperature at 2-meter height on a monthly average. We can also, copy and paste this data set here, this asset ID to see. It's this second one, if I'm not mistaken. And you can see the description about it. Pardon me, it's not the second one. It is this first one. And you can see the bands. This is the band we'll be working with. Is the average air temperature at 2 meters height on a monthly average. And you can see its temperature in units of Kelvin. So this is important when you will be using, for example, the inspector to inspect some temperatures. The values that you see returned will be temperature in Kelvin. So here we're just defining this data set, Euro 5 monthly. We're filtering. Here we're selecting first that specific band, which returns the mean air temperature at 2 meters height. And then we're selecting also here 1 month. So it's a monthly data set. So we select January of 2018, the layer of January 2018, and we use the first function to have a ee.image return and not a image collection. And then we add that to the map. Here you can note that we went back to defining visualization parameters within the map.addLayer function. And here the palette only has 2 colors, from yellow to red. So lower temperatures will have colors of yellow, and then higher temperatures will have colors of red. And then I am adding this to the map. So if I click run, the 2 data sets will load. So methane at the bottom, and then this monthly temperature at the top. So you can see areas that are close to the red color will have higher temperatures. Areas close to the yellow color will have lower temperatures. So we can see, for example, here in the Andes mountain range, we have lower temperatures compared, to other regions here in South America. Here, Russia, we have, yellow areas which will have lower temperatures compared to areas that are not so high. And you can see that for the entire globe. And you can, for example, use the inspector and compare, for example, a temperature here in the Andes Mountains. If I click here, pixel, in this inspector tab, I'll get that value of 277 kelvins at that specific point that I've clicked. So you can click other pixels as well. You can, the city you're born, a point close to where you're born, see the temperature, mean air temperature to 2 meters high. So those are another example of data sets. We worked with climate and weather data sets. Now we looked into methane data and temperature data as well. And that's the end of this section 4.